And our lesson today is going to be on arc length and radian measure. So again, you're on the right-hand side. You skip the left because we don't have a warm-up today. Is anyone familiar with the word arc and what that might mean? Huh? No? Maybe? Okay, so arc length. First of all, an arc is a piece of the outside of your circle. Okay, so we technically have multiple arcs in here, but it's that piece of the circumference of your circle. Now, we talked the other day about this point. Does anyone remember what the name of that point is? The center. It's the center of your circle. And from one end of the arc to the center and the other end of the arc to the center creates this little segment, okay? What is the piece from the center to the side of the circle called? The radius. And we're going to label this A, B, and C. And what we're going to do is, instead of finding the whole circumference like we found yesterday and the day before, is we're just going to find the length of this piece AB. Okay, so our formula for arc length, so a formula you need to know, is M over 360. Did we talk about a whole circle and a whole circle equaling 360? Yeah? No? But you know that? Okay. So a whole circle, all the way around the circle, equals 360. But I just want this piece here, which we're going to call M. This is a measure. Okay, it's going to be in degrees. This is a measure. So M over 360 times 2 pi r. Does 2 pi r look familiar to you? It does? What is it? It's the circumference formula, right? So it's my formula for circumference of a circle. So if I took the whole circle and found the circumference, I would use 2 pi r. But I just want a piece of that circle, which is why I'm using M over 360. Okay, so it's a circumference formula plus that little piece because we're just taking a piece of it. Just for reference, we're not going to deal so much with that right now, but this angle that is created at the center is known as the central angle. Okay, we'll do a whole unit on finding angle measure, but that center angle is known as the central angle. All right, so I'm going to give you this arc is 60. So that arc length is 60. And again, it's in degrees, 60 degrees. And my radius is 12 meters. And I want to find the actual length of the arc. Now, this is the degree because the central angle and the arc have the same measure. So we're talking about degrees. I want to find a distance. Does that make sense? So we have it in degrees, but I actually want to find the distance, the length of it. Okay, I'm going to take silences. We'll go with it. Okay, so the measure is 60, and it's over 360, times 2 times pi times the radius. And we're going to take our calculators and we're going to plug it in and see what you get. Just like before, you get to leave your answer in terms of pi, which means you don't have to multiply through by pi. So what do you get when you do 60 divided by 360 times 2 times 12? Sixty divided by 360 times 2 times 12. I got 4. Okay, it should be 4. So let's look at what it is. So it's 4 pi, because remember you're not multiplying through by pi. And because it's just a piece of the entire circle, our units are in meters. So your final answer should be 4 pi meters. So here's what I did for those of you that did not get 4. I did 60 divided by 360, and I kept my answer there and then multiplied it by 2 and by 12, because that's what I have here. And you should get 4. If you didn't get 4, did you plug it back in and get 4 the second time around? Okay. That's all we're doing with this. So why don't you try this one? So you're finding that arc length there. So you know the measure is 90 and you know the radius is 8. So you have 90 over 360 times 2 times pi times 8. And what did you get when you plug that into the calculator? 4. 4 pi yards. Okay, so now I'm going to ask you to think really hard on this question. What if you didn't have your cell phones? Okay, listen carefully. Shh. If you didn't have your cell phones, what would you use daily that is round? A clock. I heard one person say it. If you didn't have your cell phone, right, you would use a clock. Do we know how to read clocks? Like real clocks? Oh. Okay. Okay. Okay, so we're going to do something very similar, but deal with clocks. Okay, so we're going to draw a clock. You need to stop talking so that you can listen. So on a clock, the very top is 12, then to the right is 3, bottom is 6, left is 9, right? And then there's 1 and 2 in between, 4 and 5, and so on. Okay, but those are our 4 main points, correct? Okay. Now we're going to be dealing with, so there's 2 hands on a clock. There's a short hand and the long hand. Which one's the short hand? The hours. So the long hand is the minutes. We're going to deal with the long hand, and the long hand is our radius. Okay, that minute hand is our radius. And our radius for this problem is going to be 10 inches. So my question to you is, what is the length of the arc from 12 o'clock to 3 o'clock? Now, we're still using the arc length formula, but in order to use the formula, we need to know the radius and we need to know what? The measure of the arc. Did I give you the measure of the arc? No. I heard yes. Who said yes? Why? Okay, do you know what it is? You're on the right track. So the measure of the arc we can find. How many minutes is a whole hour? 60. Okay? But I just want from 12 to 3. So how many minutes is it from 12 to 3? 15 minutes, right? 15 minutes. Shh, we're just talking about minutes. So 15 minutes from the 12 to the 3. Agreed? And you said an entire hour is 60 minutes. Okay. Not right now. Where did we get the 15 minutes from? Because I want to know. I want to know the arc length from 12 to 3. And from 12 to 3, there's 15 minutes. Right? From when it's 12 o'clock to 12:15, it's 15 minutes. Right? 12 to 12:15 is how many minutes? It's 15 minutes. Okay. So 15 minutes and an entire hour is 60 minutes. These are the hardest problems today. What was the measure of the whole circle? 360. I have to multiply this by 360 because I want to know the measure of just this piece. So I take my minutes and I multiply it by the whole circle. Can someone plug that into their calculator? 90. Which means this arc is 90 degrees. That should make sense to you. That's a 90-degree angle. If you think about a clock, you have your minute hand at 12 and you have your minute hand at 3. It makes a right angle, or it's a quarter of the hour, and a quarter of 360 is 90. 360 divided by 4 is 90. Okay, so there's my measure. Do I know my radius? Yeah, it's 10 inches. Now I'm going to use my arc length formula. So there's an additional step with these ones. So my measure is 90 over 360 times 2 times pi times my radius, which is 10. Because the radius is 10. So 90 divided by 360 gives me what? Times 2 times 10. 5 pi what? Inches. So the length of that arc is 5 pi inches. So let's go through this again. If you don't know the measure of the arc, it will be a clock problem, and you need to figure out what it is by using the amount of minutes between the starting and the ending point, dividing it by 60, because that's how many minutes are in an hour, and then multiplying by 360, because that is the total distance around a circle, right? That is the measure of a circle. I know, a few steps, but once you know the measure, then it's just plugging it into your formula. Okay, we're going to do another one. So let's look at this clock. Okay, we're going to go from 12 o'clock to 12:27. Hold on, I'm going to do it with you. I just need you to stop talking so that you can hear me. We're going from 12 o'clock to 12:27, and our minute hand is 6 inches long. So from 12 o'clock to 12:27, and our minute hand is 6 inches. How many minutes passed from 12 o'clock to 12:27? 27 minutes. Okay? So 27 minutes out of an entire 60 minutes. Okay, that gives me a proportion for my minute, or a ratio for my minutes. But I need to know what the measure is according to an entire circle, which has a measure of 360. So in your calculator, what is 27 divided by 60 times 360? 162. Okay, now let's think about that for a second. If I went from 12 o'clock straight down to 6 o'clock, or to the 6, right? I went from 12 to 12:30. It would give me a straight line. Do you know the measure of a straight line? 180. So does it make sense that 162 is pretty close to 180? Okay, so there you go there. Now I want you to find the arc length. You have the measure, you know the radius. Let's see how you did. You have 162 over 360 times 2 times pi times the radius, which is 6. 162 divided by 360 times 2 times 6. What did that give you? Good. 5.4 pi inches. So again, there's one additional step for clock problems, so you need to find the minutes passed. So how many minutes went by? And you're going to put that over 60. Right, so you found the minutes that we have that elapsed over 60. And then multiply that by 360 to find the measure. I'm just writing down the steps that we took to find the measure of the arc for clock problems. So the minutes that passed, so from 12 to 12:15, from 12:15 to 12:45, you should be able to figure out those minutes over 60, and then you multiply it by 360 to find the measure. So multiply by 360 to find the measure is what that says. Do you need another? Actually, I'm going to give you another clock problem that I want you to try to do from start to finish. Okay? You'll do great. So you're going from 12 to 12:35, and your minute hand is 4 inches. So see if you can go from start to finish. See. So from 12 to 12:35 is 35 minutes out of 60 times 360. So 35 divided by 60 times 360 is 210. Okay, then we have 210 over 360 times 2 times pi times 4 divided by 360 times 8. You should have gotten 4.7 4.7 pi inches. Because it's 4.66666667, so you round it to the nearest tenth. Plug it in again. 210 divided by 360 times 8, really? You should have 4.7. This is the part here that everyone forgets. So they forget to find the measure. This part shouldn't be the difficult part. This part is where everyone messes up. Because if you get this wrong, this is going to be wrong. Are you okay with this? Not too bad? Okay, one last thing, and this will take like 2 seconds. So we've been looking at degrees. That's one way to measure a circle. We can also measure a circle in radians. So we are going to convert degrees to radians. We're going to convert degrees to radians. And the formula for that is so similar to arc length. The only difference is we don't have to worry about a radius. We're just looking at the measure of the arc. So we're going from degrees to radians, and we don't worry about the radius. So all we care about is the degree of the arc. So for example, if my degree is 60, I would have 60 over 360 times 2 pi. And this is going to be the only problem where I ask you to multiply through by pi. Pi cannot be in your answer. So 60 divided by 360 times 2 pi, and I want to round to the nearest tenth. What do you get when you do 60 divided by 360 times 2 pi rounded to the nearest tenth? What'd you get? 1. 1.0. Okay, so if you want to go from degrees to radians, we use our measure and we don't care about the radius, so it's the same formula without the radius. And again, you have to multiply through by pi. And that'll be in the directions. It'll say round your answer to the nearest tenth. I can even put that here. When do I want you to use what? When it asks you to go from degrees to radians. So if it just gives you the degrees and says find the radians, you use this formula. Okay? Round your answer to the nearest tenth. And then again, whoops, make sure you read the directions, because if it says round to the nearest tenth, that means you're going to multiply through by pi. If it says leave your answer in terms of pi, you literally leave pi in your answer. Okay? Questions?